Hi, last time we stopped at creating the config file, and we tested the file here at the bottom using this asynchronous function. So let's comment it out. And today we will continue the previous videos where we started looking at VeChain, how we can derive multiple accounts using one mnemonic. And here was the file where we actually derived it. This is the environment file where we posted all the results of this derivation. So we have 10 accounts here, or 9 accounts. These are the public keys. These are the private keys of all those accounts. This is the mnemonic that we used for deriving those. This is just a reminder of what we did in our previous videos. So if you haven't watched them, please do. And today we are going to mint NFTs to a couple of those accounts. Let's mint to several first accounts and see how we can transfer those NFTs using the bridge. We're going to do everything only from code. We're not going to interact with any UI. This way we'll be using our XP.NETWORK library, which this tutorial is about. So let's go to our src folder. Let's create a file and let's call it mint.ts, like this. And let's start creating the mint function. As we will be creating this function, we will see what we have to import from which libraries, and we will do that on the way. So I won't import anything in advance. I don't want you to be confused why we are importing this and what this thing is doing. So we will do it on the way, and you will see immediately what libraries we're using and what functions or objects we're pulling from those. So let's create a function. Let's call it mint. Let's make it asynchronous. And let's open the brackets and leave some space for the arguments. Let's turn it into an arrow function and prepare the curly braces to host the body of the function. All right, so let's first, let's also leave some space here for us to be able to write, and so that we see that this is the body of the function. And let's start writing the body of the function like this. So let's create a transaction. Let's call it const transaction. Await. And this transaction will actually await our UMT, which is a user NFT minter. So here we will need to get this object from somewhere. So let's go to our parameters and let's import it. Let's import a UMT, which will be the type of user NFT minter. And now it says that we don't have this, but we can actually import it. Okay, so let's do that. Let's import user NFT minter from, okay, we definitely imported from XP.NETWORK. Okay, but as you can see, it says XP.NETWORK doesn't have this member. So what do we have to do to import it? We can, oh, sorry. So that's correct, that it doesn't have it because we also have it in a different library of XP.NETWORK, which is called XP.NET Web3 contracts. Okay, and we don't have this error anymore because this repository is pulled together with XP.NET, with our library, and we're good to go. So now nobody's yelling at us. We don't have any more errors. We can continue. So as we have this UMT, this is a smart contract. We call it user NFT minter because it allows anyone to mint NFTs without any limitations. You don't have to be the owner of the contract. You don't have to have any special roles. Do not use this contract in production. This is something that we wrote just for testing purposes. And this is what we're going to use here. For testing purposes is just because it has no limitations, no security mechanisms, but it's good for minting NFTs on testnets where you don't have marketplaces where you can just go and buy some cheap NFTs for testing. Here, you better mint those NFTs yourself, and this is the contract that plays this role. Okay, so that's why we call it user NFT minter. We also use this contract on some mainnets, but also only for testing. No NFTs will live there in production. Okay, since this is a contract, we can actually have access to this contract like this. We can say connect. So the first thing, we have to connect to this contract, and let's connect our signer. But again, as we can see, we don't have any signer. However, we can extract it. Okay, let's do it like this. Let's import setup that we created on one of the first videos in this series from, and we'll import it from config like this. Okay, so now we have the setup, which we can use for importing common objects that we're going to need. Let's say const like this, signer, okay, equals await setup like this. Okay. And okay, I guess we better do this. We better import the signer from the arguments of this contract. Okay, and it's going to be ethers, providers, JSON, RPC provider. This is the one we need. JSON RPC provider, here it is. Okay, and thanks to Visual Studio Code, this ethers library was automatically imported here. Okay, but now we have a problem with this because we don't have a comma. Okay, and we don't have a comma here. All right, and I guess let's remove it from here for now. Also, setup is yelling at us because we are probably missing something. Yeah, we are missing this. So we're gonna need the private key that we're going to be using, and for that we will need to import config here, import config from .env, and I prefer to immediately call this config when I'm writing config like this. Okay, and now we are able to use our environment variables, but let's actually do it here. Let's also create an asynchronous function, anonymous asynchronous function here, like so. Let's also call this function immediately. Let's make sure that if any errors occur, we immediately catch those errors. Actually, we'll just write the error in the terminal and we will exit. So in order to exit, we can do it like this, import, no, this exit from process. Okay, so in order not to close the terminal with Control C, which is annoying, we better just tell it to close by itself, and we will put a non-zero code to show that there was an error. And here we will exit with a 0 code to show that everything went fine. And this is where we're going to call our mint function. So we can actually call it simply awaiting this function. So it can just say await mint. Okay, and it's going to ask for some parameters, and we will move this here, because this will allow us to call this mint function from anywhere else. We can actually even export this function so that we can use it elsewhere. And setup is yelling at us. It says that there are some parameters that it wants. Okay, the first parameter it's looking for is the private key. All right, so we can say, we can also actually import env from here, from process. And we can say that we will call env, and we're going to need some private key that we want to use for minting. So for example, if we want to mint an NFT for the first account, so let's take this private key and let's put it here like so. Again, it's unhappy. It's not sure that this private key is there. So let's put an exclamation mark to calm it down a little bit. And as you can see, this mint function is pretty much happy. But we need another parameter, which is the signer. So let's import the signer from here. And now we can provide it here, like this. Okay, something else. Against user NFT minter. Oh, okay. So here it was actually looking for a user NFT minter parameter. So let's create it actually. Yeah, let's say const umt of type user NFT minter, which we already imported, equals user, not with the capital letter, user NFT minter, actually factory, like this. And this is something else that we are going to need to import. Let's import it from here. So let's make it easier to read, like so. Let's put a comma here and say user NFT minter factory here. Okay, and there's no error here anymore. So let's keep moving and building it. Okay, this line is pretty big already, so let's move to another line and also say connect, and let's connect to the contract address that we previously deployed for this purpose. Okay, I can show you how to deploy the contract in some other videos, but right now let's just provide the address of this contract like so. And still it's not very happy because something else is missing here, which is it's missing another parameter, which is the provider. And we don't even have this provider because we haven't imported them from provider. We haven't imported them from setup. Okay, setup is also unhappy because it also expects, so here is the private key that we were supposed to provide. So let's say env, and let's go to the env file where we can grab this thing. Okay, now it's not yelling at us anymore because the other network parameter is arbitrary. But just for the sake of training, let's anyway put it. So we can do it like this. We can call network. It's automatically imported from the config file. Yeah, but it's a type that we created, which is an enum. And let's select the network that we want to mint our NFTs on, which will be testnet, like so. Okay, so setup is not yelling at us any longer. Now signer. Okay, so it says that signer doesn't exist on type. Let's go and check what we are provided as a wallet. Okay, so it should be a wallet rather than a signer. Okay, so for most EVMs, it's called a signer, but here it's called a wallet. All right. So this is a wallet. Let me see. Don't we really have a signer? We don't have a signer, but we can actually create one. It's not a big deal. Okay, we can create a signer right here and then export it because it's actually more convenient to have a signer rather than create it there. So let's say const signer equals provider get signer, and all we have to provide here is the sender. The sender, which we also don't seem to have. Okay, let's create a sender then. So const sender. It will be a type of string, and we can get the sender like this. We can say wallets list. Let's take the first element because we actually have only one, and let's extract the address from there. And there we go. We have the sender, and there was a typo here. So now we have the sender and the signer, which we can add to the exports here, sender and signer, like so. Okay, so we've updated our setup function a bit. Now I actually don't need the wallet here anymore. Okay, because we conveniently have the signer like this. Okay, let's see. Why is it unhappy with the provider? It's because I also made a typo here, typing too fast. Okay, no errors here. Okay, let's see what's the problem here. Is not assigned to prime user NFT minter. Of course, it has to be UMT like this. Okay, and signer, it is JSON RPC signer. Is not assigned to JSON provider. Okay, let's figure out why. Okay, let's see what we got here. Let's get signer sender. Let's see what it returns. Okay, ethers, providers, JSON RPC signer. So it does return what we need. Let's try maybe setting a property. Okay, ether, type ethers, providers, JSON. Now let's select the right one, provider. Okay. JSON RPC signer. Let's now check what this wants. Oh, okay, so now I see the error. The error is here. Okay, so I provided the wrong. Okay, here we have to expect the signer, and now it matches. Good. Okay, so now we can call this mint function. It will be awaited. We have the user NFT minter. It's a contract, which we can access by the code of this contract. And this factory will make sure that we have the ABI and the binary of this contract. We can import it from that library. And you can actually do too. I can give you the code of this contract, and you can deploy it yourself if you don't want to use ours. but you're actually welcome to use ours as well. You can now see how to import it, how to use it. This is actually the contract for the testnet, which is already deployed on VeChain, which you're welcome to use. And let's continue with this function. So, okay, we have the transaction, which awaits user NFT minter. It connects with the signer. And let's keep moving. Right. So why we even call this is because we want to mint. Okay, we want to mint, and here we're going to need a URI. As you can see, it's expecting a URI string, URI. Okay, so again, because we want to call this function from outside this file, eventually, let's also add this URI parameter here, type of string. Okay, now we have it here, and now we need to provide it here. Okay, what we can do is when I prepared for this video, I actually wrote the code and tested that everything is working. And I also went to Pinata and I minted an NFT from just some print screen that I made. And this is here is the link to Pinata with a CID of what I deployed. Here I have a JSON with metadata of this file. We can actually go and see it somewhere. Just a second, let me show you what we have over there. Okay, I'll pull a tab from another screen like so. Okay, let's place this link here, just for you to understand what we're doing. So this is an NFT metadata. It was created in accordance with standards. As you can see, it takes some time because it's IPFS, and IPFS is usually slow. So it's going to take some time for this to load. Okay, even though it's a small text file, which is JSON, it still took some time to load. And this is the minimal structure that an NFT metadata should have. So I called it testnet1, description example NFT for demonstration. And this is the image that I also uploaded on Pinata before I created this file. Okay, if you want to see what there is, we can also click this and we will see some print screen that I made just for this. Okay, this is the first wallet in the array of the wallets that we're creating in this tutorial. Okay, as you can see, it ends with 5523. And if we go here, you will see that it's 5523. Okay, this is this wallet. Okay, which I created for this tutorial. So we are not violating anybody's rules, anybody's rights. Everything is absolutely legal. This is something that I created. It doesn't have any value, but still it's good for testing purposes. All right, so it seems like we have provided all the necessary parameters to the minting function. And let's see what else we're missing. But just in case something goes wrong, let's actually catch an error. Okay, let's catch an error like this. And let's also create an internal callback function. So in case there is an error, we will see it in the terminal. And let's also exit with a non-zero code to show that something went wrong. Okay, and in case everything went fine, let's do this. Let's also console log. So let's take this transaction and let's type the hash of this transaction like this. All right, seems like we are good to go. Okay, that was that easy. This is the entire file. In case you missed something, you can quickly copy it from here. And let's also do this. Let's go to the package file and let's add another script to conveniently call it. Let's call it mint. Fortunately, Yarn or NPM doesn't have this command so we can safely use this. And let's also say TypeScript and node, because the file will be converted to JavaScript in the dist folder. Again, I misspelled it, dist, and mint. This time it will be called JS for JavaScript. Okay, seems like we're good to go. So again, let's see what we're doing. So we are calling this mint function. It will talk with this user NFT mint contract to mint an NFT. For this account signs this transaction, and its public key is also used to provide the information who will be the owner of this NFT. And this is the NFT metadata that we are providing, which will be stored on the chain, pointing to this NFT. All right, so let's call it. Let's say yarn and mint. Right. Let's probably open the terminal a bit more. This is an on-chain transaction, so it might take some time. We actually have to connect to the blockchain. In the background, our JavaScript library, which is called XP.JS or XP.NETWORK, is used. This library is connecting with the blockchain. In this case, this is VeChain testnet. It's connecting with a smart contract and mints an NFT. Okay, so as a result, since we just asked it to console log the hash of the transaction, as a result, all we have is a hash. So let's do this. Let's go to the blockchain. Let's say testnet VeChain Explorer, like this. And let's check this transaction. And fortunately, it says success, which means we have an NFT minted on VeChain. Let's probably try to check some clauses. Maybe we'll find something interesting here. Yeah, okay. As we can see, this NFT was minted directly with this link, which we just provided. And here's how we can mint multiple NFTs for multiple accounts. So all you have to do now is you just replace this account with the accounts that we created in a loop for this mnemonic, and mint more NFTs for testing. And the next time, in the next video, we're going to transfer those NFTs using the same XP.JS library, using our bridge from code. Thank you for watching. Don't miss our videos, subscribe to our channel, and see you next week. Bye.